You're all jealous my hamstrung here.
Jeff, what if you shit it with something that's not cardboard?
Like sheet metal? Like a washing
Oh my god, that totally work. Yeah.
I'm good. Hi, my name is Sam Hoteling, one half of C Team 7. We are working with SOH Wind Engineering, a Dutch consulting firm that operates two large, closed-loop subsonic wind tunnels in Williston, Vermont. SOH performs analyses of various structures under wind loading and calibration of anemometry equipment. SOH's reputation relies on accurate measurements of airspeed as a function of tunnel location, but their current method of obtaining this data is slow and labor-intensive. Thus, SOH Wind Engineering seeks a fully automated system to maneuver one or more airspeed measuring devices in a cross-section of a wind tunnel and record airspeed data. Such a project has many requirements. The traverse device must move in 2 degrees of freedom, vertical and horizontal. The pitot probe or hot wire anemometer must reach within 1 inch of the walls. The pitot probe or hot wire anemometer must reach within 1 millimeter of the requested location. The traverse system must be compatible with the pitot probe or hot wire anemometer. The client requests that LabVIEW be used for operation of device and recording of data. To reduce interference, the device must block less than 1% of airflow in a 3 meter by 3 meter tunnel cross-section and less than 2% of airflow in a 2.5 by 2.5 meter tunnel cross-section. The pitot probe must deflect less than 1 millimeter from the direction of the airflow under all wind loading conditions. The measuring device must be removable in less than 1 hour by 2 or 3 people.
Hi, my name is Chris Andriani and I'm the second half of C Team 7. We will be using LabVIEW to do several things. The first thing, read in coordinates defined by SOH themselves. Step 2, LabVIEW will read in those coordinates and turn those coordinates into a defined number of steps to send to the motors. The motors will then move to those coordinates and stop. Once all 3 motors have stopped moving, LabVIEW will then trigger their data acquisition software to start recording voltages at that location. The voltages can be converted into wind velocity measurements and output into a text file.
To test the device, digital calipers are used to measure the movement of the motors. Data was entered into an Excel spreadsheet and analyzed using Python.
Run it! Running! The visual interface has 2 tabs of operation, a setup tab and a data tab. The setup tab is where tunnel technicians will handle the input for the validation procedure. This includes all tunnel calibration parameters, a text file containing all the coordinates, device handling meaning the Arduino software, and the data acquisition software. The data tab shows real-time the coordinates being measured, a visual display of the cross-section with each coordinate, and a real-time velocity measurement of the wind speed at that location. These are amazingly accurate. They're not dropping steps either.